So why don't we get started? So as everybody knows, I have it in big red letters there. This meeting is being recorded. We will post it on YouTube and social media afterwards, also on the website. So if anybody misses today, we can still share it. It'll be publicly available. Just so that everybody knows, SOP Technologies, we are a local company here based in Miami. We primarily focus on addressing stormwater pollution problems like litter getting from the streets out into the waterways. But because of this issue regarding fish kills, I contacted Environmental Compliance Equipment. So they're a company that's based in Florida, and they have a lot of organizations here. I'm not sure if I want to name the customers, but I'll let them mention their customers. And they essentially oxygenate water, and they have a system that does this. And because of the urgency to do this, I asked them if they would be available today on a Saturday afternoon. And I'm glad that for those of you that could make it, that are here, because it's an extremely urgent matter. I wanted to have this call maybe sometime next week, but we see that that's not possible due to the speed. So we're going to get right to it. We're going to get to the focused questions that people have. How soon can this be implemented? What is the technology? How much does it cost? What are some logistical challenges? Questions that they have for the community members. And with that said, I'm going to quickly go to the next slide. This is a one-slide presentation where we have a bunch of talking points. And then from there, I'll quickly introduce the team from Environmental Compliance Equipment so that they can talk about their system and what it does. But before we get to these talking points, why don't we have a quick introduction? Barry, do you want to quickly introduce yourself? Then we'll go to Andrew and then George.
Sure. Thank you, Emilio, and thank everybody for joining this call. Myself, I'm a degreed engineer, been in the process industry and various industrial applications for numerous years. I've been working in water treatment since about 2010, and I've worked with George and Andrew various applications over the years. My expertise is project management, more consulting project management, hands-on, and that's what I'll bring to the table here with George and Andrew's team.
Thank you for that. Andrew, do you want to give a quick intro?
Andrew Hyatt. I'm the owner of Environmental Compliance Equipment. We're based in Stuart, Florida. I've been in the water business since 1992, mainly in the industrial wastewater side, cleaning operations, cleaning up industrial style wastewater. Got into this nano bubble technology several years ago through George, basically, and from that we've incorporated that technology into a lot of our systems that we do on the industrial side, but also have it deployed in these trailers for treating, waters that are, an issue that you have done in the Biscayne Bay, with low and dissolved oxygen, algae remediations, and this such and that. So we basically designed and built the equipment that you see in the slides, and sell it out to implementers, and we also implement them ourselves.
Thank you for that. Thank you, Andrew. George, would you like to give an intro?
Yes, thanks to everybody for joining the call. I am actually the importer of the technology from Japan. Been working with Mr. Ansai on this for the last 5 years, and longtime colleague and co-worker with Barry Hinton originally, when we were both at Thermo Electron, Thermo Fisher Scientific today. Been in the environmental business for a long time, since 1982. I think I'm the old man on the call. And Andrew and I came to Andrew with the concept of the nano bubbler, and we decided to work together to help introduce this technology in the United States for Mr. Ansai, and been in the environmental business for a long time. Everything from soil, not a little bit of air, water treatment, environmental engineering, applications engineering, and sales service. Between the three of us especially, we've done a lot, and this technology can really help in the oxygenation that we're going to be discussing. It uses a nanobubble technology, which, as you folks ask questions, you know, between the three of us, we'll answer the questions for you.
Great, great. So we do have a few talking points over here. But before we get to them, I know that on the website where there was information for signing up to join the webinar, we've already included some information about these nano bubblers. But does anybody on the call have questions from a technical standpoint before we get to the talking points? Please feel free to unmute yourself.
Hey, this is Dave Dobler. What is the difference between, you know, what is special about the nano word that you're using versus just regular aeration?
I'll take that question. The biggest difference, Dave, is the fact that the nano bubble itself, first of all, you can't see a nano bubble. The size of the bubble is 10 nm, 97 nm, 98% of the bubbles. The important and interesting thing to the scientists on the phone and engineers on the phone, the nanobubbler, when the water passes through the nanobubbler itself, we actually put the gas into a carbon ceramic stone, and a negative ion, as you flow the water across the surface of the stone, the Reynolds and shears of the water movement will remove the bubbles from the stone and enter them into the water column with whatever gas we want. The interesting phenomena is that it takes on a negative ion on the liquid gas interface, and it creates a high pressure outer shell. So what this causes is, between the negative ion and that high pressure liquid gas interface, the bubble loses its buoyancy. The bubble will literally sink in the water and continue to shrink. So it sinks and shrinks in the water, as opposed to all the things you learned in engineering school about the rise of bubbles, Henry's Law and Stokes and all the others, Laplace and all the other scientists. We do not lose the bubble to atmosphere. We do not lose the oxygen to atmosphere in this case. We can put any gas into any bubble that we want, and that phenomena will happen. So, Dave, the short answer is the bubble remains in the water for a long period of time. The period of time is dependent upon the other chemistry in the water column. And one of the telltale signs is, we did the National Park Service job back in November. We took measurements the day after treatment, 11 days later, and then 33 days later. When we arrived at the job site, the dissolved oxygen number, Dave, was 5.1 to 5.4 at 4 different reporting stations. We took samples close to the surface, 2 feet down and off the bottom of the surface. When we left the job site, the whole 7-acre lake was 21 to 24 milligrams per liter of dissolved oxygen. 33 days later, it was still at 10.1 to 10.4. And the lake had an interesting thing happen to it, where migratory geese decided to take up residence for a little bit over 2 weeks. Each goose will defecate between 5 to 7 pounds of waste. So I think it's fair to say, and I asked Dr. Sellner up there, is it fair to say that that DO number would have been even higher 33 days later? And we both laughed, and he said, yes, it could have been a little bit higher. Moral of the story is the gas stays in the water for long periods of time, and you will not lose it in atmosphere.
Is that the concentration of bubbles in a cubic centimeter is massive. There are so many bubbles in there that
Very good. Yes, that's a very good question, observation. The bubbles, one of the things, the parameters that we measure and through a nanoscope is the bubbles of density per centimeter cubed. 98% of the bubbles, as I mentioned, are 10 to 97 nm in size. The first scope that we did the test was with Malvern Analytical. The first readings took 10 dilutions of water. We made so many bubbles that the computers and the programs couldn't read. There were so many bubbles, they had to dilute it. Now, to be clear, water was what we call supercritical waters. There was nothing in the water. There weren't any particles in the water that you could really measure. And we read 10 to the 9th. The new scope that they have just developed and are still out proving will read 10 to the 15th power. We know that we're at 10 to the 12th. So we're in trillions, literally, it's hard to believe this, trillions of bubbles per centimeter cubed in that little tiny space.
So George,
yes.
so George, with that said, how would this compare to the longer term systems that we often think about? We think about a fish tank, for example, with air bubbles that go up all the time. How does it compare in terms of how quickly can you increase the oxygen level in a water body?
Emilio, it's going to depend on the water chemistry that we're talking about. A freshwater lake's going to act different than a saline ocean water. So ocean water, there's a lot more things in there, to just be generic, that the oxygen can react with. So it would take a little bit longer in the ocean water as opposed to in freshwater, as opposed to a supercritical nuclear clean water that would be used in a nuclear reactor. Another example of its staying power, when some of the first tests were done at Malvern Panalytic, and we'll share the data with anybody that's interested. We can send you the reports. Interesting fact, they took the water sample, and all they did is they took that same water sample, they put a piece of cardboard over it, they put it up on a shelf. When they came back to investigate the new and do a test with the new nanosite, excuse me, they realized that they had left that water up on the shelf, and it was from 60 days or more. I don't know the exact time, but it's at least 60 days later. They took it down and they measured the DO in the water, and the dissolved oxygen number was still very high. Unfortunately, I don't remember what the number was, but they were like astounded that all they did is they took a piece of cardboard, put it over the top of the beaker or the jar, they set it up on the shelf, and they realized that they could measure the nanobubbles that were still in that water.
A quick question for you. This is actually Seth Bloomgarden from Surfrider. Have you determined about how far a geographic area your system would be able to cover?
That's going to depend on the flow rate. You're not going to go treat the Gulf of Mexico. That's just not a reality. The largest body of water that's been done has been done in Tokyo Bay, where the zone that they were doing this in was virtually a dead zone. This is the best way that I can answer it. It's been proven that over time, given enough time, that the dissolved oxygen numbers, because remember, you got wind, you got tidal influence, you got currents, that it can carry the nanobubbles. The nanobubbles will roll. The goal is to flood the area with nanobubbles. So it's one of the things that I notated on I think it was Rachel that gave out a map with all these hotspots, and I saw section number 51. I call it jokingly Area 51. Looks like a little
bit east of Pelican Harbor. Mm-hmm.
It's the harbor, and it's enclosed on 3 sides. And I said that would be a good spot for us to start to prove the efficacy and our ability to raise nanobubbles in a shorter period of time, because it's somewhat contained and it isn't as influenced a tide. You're going to get a high tide, low tide is going to move nanobubble. So it's really a loaded question on what's the biggest area that we could do. The largest area to date that I am aware of has been in Tokyo Bay, and at the extension of a runway, another runway project for one of the airports in Japan, excuse me, where they were doing digging, and it was really the odors that were creating issues. They wanted to eliminate the odors. They just used standard oxygen, a flow rate of 1,584 gallon a minute of the 150, and oxygen that they pumped back into the water, because another interesting phenomena of the nanobubble, as it continues to shrink, it implodes upon itself and it creates a hydroxyl radical, which helps to remediate the water as well. So the honest answer is, I don't know.
Well, the longer that the system is operating and infiltrating the water column with nanobubbles, the more they'll spread out, because they react with a Brownian motion. They're always bouncing off each other and moving out. The tide's going to take them out. So it's more of a time scale operation. As you continue to inject nanobubbles, they will spread out through the water column. But as far as that, good.
Somebody's speaking. I think you're cutting out.
George, a question from Scott Stripling, Surfrider.
Yes, sir.
Is the shallow depth of the bay, say 4 to 10 feet, going to impact your operations or the lifetime of your nanobubbles?
The lifetime it won't impact. The depth doesn't matter. The bubbles will sink. If we have the ability to flood a water column, we will take what I call them boat fenders, and we'll actually have the effluent pipe about 1.5 to 2 feet below the surface, because we know that a lot of those bubbles, they're just going to roll the negative ion, and because of such a high concentration of bubbles per centimeter cube, that they literally, the bubbles will bounce off of each other and create this rolling effect, if you could see my hands.
Yeah.
And they will continue to shrink. They will also be consumed by the water column with the other chemistries that are in it. So the depth doesn't matter. It would obviously take longer if the water was 50 feet deep for the bubbles to reach down to the bottom. An interesting phenomena that occurs when we do get to the bottom, it actually helps to restore the microorganisms, the friendly bacteria that are in the silts and the sands and the sediments at the bottom. In a wastewater treatment environment, we actually reduce sludge. We see sludge reductions between 30 to 35% over time in a confined space.
Great,
So
thank you for that.
matter.
So we're going to have a network of sensors that will be constantly monitoring the chemistry of the water as this process goes on. Make sure that nothing gets out of range.
Well, it won't get out of range because the volume of water is going to be so large. As far as sensors, there's onboard sensors on the trailer itself and in the piping of the trailer, where we know that we're producing oxygen. We know that what the flow rate is. We know what the dissolved oxygen number will be. When it enters the water column, it's obviously going to become diluted in the water column itself. As far as in the water column, another important point, temperature stratifications will not affect the nanobubble. It will pass through. As you go deeper, the water is theoretically cooler and cooler. We won't have any problem getting the bubbles down to the bottom, given enough time to get down to the bottom of the lake. So one of the points that the other fellows were making was, I think it was Andrew, given enough time, those bubbles are going to be the most concentrated close to the effluent pipe and the least concentrated on the other side of the bay, obviously.
George, so I guess the question was, are there going to be, or can your company provide some sensors to show the effectiveness of this system at increasing the oxygen content in the water body, not in the machine itself in the trailer?
In the water body, what we do on a typical job site is we'll have a tethered probe that can read dissolved oxygen, pH, and temperature. And maybe Barry, did we lose Barry?
He's there. It looks like he's unmuting himself now.
Barry, do you want to address that? We don't, other than tethered probes, we do not put things out in the body of water, because typically, like what job we're on right now, we'll go and pull water samples.
Okay, Barry, do you want to take it from here? And I do have some questions from the chat, by the way.
Sure, thank you. That's a great question. The answer to that is yes. We will have on board. We will have in-water monitors and we'll have it. The monitors will be at a certain depth, a certain distance away from the so-called intake to the process system. So we'll know the effect close to the suction point. We'll know exactly what the dissolved oxygen levels are after injecting the nanobubbles in the water. So the answer is yes.
Great, thank you for that. So here's a question that I have actually from Senator Jason Pizzo. He's asking, can we get all of this in a summary comparing efficacy, costs, etc.? Also need full bios on all principles and entities.
Yes.
Okay, great. Andrew, thank you. So I'm assuming we can do that rather quickly, right? Within the next few days, so that we can have some quick information out there.
Yep.
Yes, that shouldn't be a problem.
Thank you for that. Another question here from the chat. Has the longevity of the effects been shared? Maybe we should include that information when we create some kind of a package with all of these details.
Case study, Tokyo case.
Well, we do have a case study for the national parks process we did up there. George can talk about that. Sure.
I have draft documents that I will ask Dr. Kevin Sellner up in Maryland to distribute it to the group, and he always says yes, but out of courtesy, because he and Dr. Ferrier are the authors of the National Park Service job, I asked permission for us, so I just need a day, and within a day I can distribute it to the group if you send me your email addresses.
Okay, great. Thank you for that. So here's some other questions, and they do get into the talking points. The one is the more important one probably right now is timing. How quickly can we get one of these units out there?
More likely by Tuesday, no later than Wednesday. It would be our one unit, which is a smaller unit. It operates at about 132 gallons a minute. And then we have another unit that's up in Jacksonville right now, working on a lake that might not be available until the end of the week. And then we have an additional unit that's actually installed up in Disney that we're doing some work with them, some testing on the living season area. Then we'd have to go up there and burn that one. So that would take a few days. So at least one of them could be down there Tuesday, no later than Wednesday, and then the other two could come in later on. That would be a combination of two 132 gallon per minute units, and then the 400 gallon per minute unit, which is operational up in Jackson.
Good to know. So does anybody on the call have a question about this, about timing and getting these things out there, some limitations, some concerns? Please feel free to unmute yourself. Senator Pizzo.
Hey, Emilio. Hey, guys. Sorry, the video was off. I just landed in Miami to go vote and then I have to go back to Tallahassee. But just kind of the particulars. We had this with PPE, with, all types of vendors and all types of ideas and all that stuff. The first thing I would recommend, because obviously Florida is the epicenter of a lot of these environmental issues, but get the paperwork done on being certified. It's actually an easier window right now because of the pandemic, because of services that can be offered. Get on getting certified by the state to be a vendor, the county, whatever you have to do. I know Sean McCracken's on this call, but get that stuff done just so that everything's properly vetted, so you guys can move forward on a quick basis. You may actually be able to have the equipment a lot faster than you get certified, to do so. Just my humble suggestion.
Oh, that's
Emil?
I had a question about what regulatory agencies. Barry and I have done a lot of
I don't,
this kind of emergency response.
right.
So,
I don't mean to cut you off. I apologize, but So we corralled yesterday within like 12 hours time. Everybody jumped on a call. The lead on this is actually going to be Gil McRae from Fish and Wildlife.
Okay.
The chair is Spotswood, and he's aware of it, but it's going to be Gil McRae under the guidance of Eric Sutton, who's the executive director. He was also on a call. If you guys want to shoot me an email, Emilio, pass my email around, and I'll send the link to the YouTube. We put it up on YouTube, the Zoom call. Also coordinating is the DEP, headed by Noah Valenstein. He's probably pretty good at his job because he's held over from the last administration. He survived. And then obviously locally we have, Miami Waterkeeper, Clean Up Miami Beach, David with Volunteer Cleanup. So everybody's sort of on board and everybody's enthusiastic about doing something. I'm getting 50, 60 social media texts about, what do I do with the fish if I go out my boat today? What do I do with it? So we're coordinating. We're going to be mapping out where dumpsters can be had. The county seems to be amenable to it. Talked to Lee Hefty also from Durham today that you also want to be in coordination with. So if you watch the YouTube link, even for 20 minutes, if you'll favor me with 20 minutes, you don't have to do the whole hour, but you'll see, who the parties are and who's involved.
Okay, perfect. Thank you.
The governor's office is also aware of this.
Okay.
Thank you, Senator. Much appreciated. Dave Dobler, I know you had a comment.
No, I mean, my question is, well, I guess my comment is that Emilio with SOP is set up to do business with City of Miami and also City of Miami Beach, I believe, from a procurement standpoint. The question, I'm not sure if there are other regulatory hurdles that need to go through. It's really just who pays for this. But I guess my question is there kind of an offer on the table? Are you guys going to send one unit down, show us how it works, demonstrate that it's working, and then people cut an emergency purchase order, or is this an upfront rental that you're asking for a commitment for? Talk to us a little bit about that.
Andrew or George, do you want to take that?
Sure.
It would be an upfront committal. It would be just like if we're doing work with another lake somewhere. So we would, we would send a proposal, get the proposal approved, and work off that.
Yeah, normally this goes through like a RFP, or starts as an RFI, then goes to an RFP. It's kind of hard to the group needs to realize it's kind of hard to throw a number out there when you don't really know what the total scope is. Little simple things like the distance of the machine to the actual body of water, gen sets, can we run 24/7? Do we need lighting? In some areas you may need lighting, in other areas we don't. We're used to going to a job site and scanning it and looking at all the different obstacles that we have. So we could throw a number out there and lose our shirts, or we could throw a number out there and be overpriced. So it's hard to address this. So what we tend to do is we can give you a range of numbers, but then ask the group or the who's ever taking the lead, paying the bills, to take into consideration. If they can provide gen sets, that reduces our cost. Typically, we like to control all that so that there's one focal point, and Barry can elaborate a little bit more on this, because logistically, to be staged at 3 or 4 different locations at any given point, we need to have everything replicated. Site 1, 2, and 3. Site 3 may require more hose, or may have some issue that we have with the elevation in relationship to the machine. These machines are built to be able to do some lifting of water, but not 13, 14 feet above grade would be a problem. We'd have to accommodate with additional pumps.
Thank you for those details. Andrew, did you have another comment on that? So then we can get to the next talking points.
If it was needed, we could go down there tomorrow and look at some sites where they want to look at putting these systems, so we could have a good idea of what the challenges might be, getting the trailer in there, putting the ancillary components around there. So that's something we could do for sure. just to kind of
Okay.
get some kind of a proposal.
Okay, so you're talking about coming down here to have a better sense of things, to, I guess, better gauge potential costs and logistics. I guess we can maybe work with some of the local nonprofits that understand these areas. Rachel from Miami Waterkeeper already gave examples of some areas that have a great need. I know Dave mentioned Pelican Harbor before, and also a little bit east of that site. So that folks on the call have a general sense, at least, of pricing that we're talking about here. What would be an example of potential pricing for one of these units?
One unit, we'd probably looking at in the $6,500 to $7,000 a day range to staff the unit, operate it, fuel, generator rental, the whole operation. You have to have somebody there on a 24-hour basis and have 10 or 2 folks down there that would operate, set up the system initially, and then alternate running the system on a 24-hour schedule. So,
Okay. Okay, so your phone is cutting off, by the way. It's very hard to hear you. So that for those that couldn't hear, that was about $6,500 to $7,000 a day. If you have a lot of the equipment already included in that, and the personnel to run that equipment, is that right, or
Yes.
is there something that I missed there?
Yeah, that's correct. That would include the cost of a generator. A lot of people, the folks at DERM and DEP, Fish and Wildlife, and even private foundations, if they have gen sets that they want to contribute to that price can be reduced some. And fuel, and if we're going to operate 24/7 and we need light stands, the counties have light stands, they have gen sets. So we're willing to work with the group and to help to reduce costs, because if you got an asset sitting around doing nothing, we might as well use what the county has. But it's got to be a reliable piece of equipment. And really, Barry should be the one addressing these questions.
Okay.
I have a question on that.
Dave Dobler, do you want to go ahead, and then Barry?
Yeah. Can you run this off of electricity, like 220 volts? Like plug it in, because DEP is over. DEP is actually over in Pelican Harbor. That's where they're based out of. And so between the Seabird Station and there's probably some juice.
Okay, thank you for that, Dave. Barry, do you want to take that?
Yeah, sure. Dave, the equipment itself is every piece of equipment that we would supply is 3-phase, 230 volts at various kVAs. The answer to that is yes, we can run off utility power if it's available. Our price that Andrew just mentioned was a turnkey price per piece of equipment. The one thing that doesn't include is testing, analyses, and whatnot. And I'm sure the focus on that is very well covered by some other group. We can add that in if you'd like. However, we've worked with government agencies, and they typically like to do their own testing and analyses. Does that answer your question?
Yes, it does. I was more looking from the standpoint that part of this is likely caused by long-term climate change, and so if we don't have to run gasoline-powered generators, is quicker, cheaper, easier, or cleaner to operate just off of the grid. So that's where that question came from.
I got you. Good point. And by the way, they're diesel-fired, but that's even worse. So.
Well, I know the city of Miami Beach has diesel backup generators hanging around, so maybe we could commandeer one of them.
Okay,
for the stormwater pumps.
Okay, great. So on the talking points here, we were talking about locations of greatest need for implementation. It sounds like we're talking about Pelican Harbor potentially being one of those areas that makes the most sense because of the equipment that's around there. Dave, or maybe somebody from Surfrider or Miami Waterkeeper, if you're on, does that sound like potentially a good spot based off of the observations of fish kills?
I would, this is Seth again from Surfrider. I would probably recommend Pelican Harbor, maybe Morningside Park, and then maybe a location in Edgewater All of those areas seem to have a tremendous amount of impact, and it might be able to help us measure what's going on in each.
Okay, great. Thank you for that. We also have some more comments here. North Bay Village, just east of that, and the fish kill is massive there. So maybe the team can work on looking into those sites. And Andrew, you mentioned potentially somebody coming down here. How realistic is that for someone to come down here this weekend to at least take a look?
I can come down tomorrow for sure. Absolutely. I'm just a couple hours away. I'm just up in Stewart. So.
Okay, great.
Let me know when I gotta go and who I gotta meet there.
Okay, sounds good. So we'll coordinate. I'll send some emails to the local environmental groups here in this area. So does anybody else have any questions on this call? Nobody right now? Okay, so here are some questions that we had already written down that the team from ECE, from Environmental Compliance Equipment, had. You know, what are some organizations that might fund this? What are some funding sources? I know that we kind of touched upon that right now. Does anybody know of an organization that's has already committed some funds to address this? I know there are a lot of environmental groups doing things for free, but if there's going to be...
Well, you know, on yesterday's call with Senator Pizzo, it was mentioned that if there is a plan in place, there may be state resources that are readily available for allocation. So I think that would be the first place to explore. This is, again, Seth from Surfrider.
Okay. So state funds potentially.
Well, I think the bigger problem is how we demonstrate to scientists within NOAA, DERM, DEP, FWC. How do we demonstrate that this is going to be an effective solution? I think that's the big question, because you know they're not going to be interested in it if they're not convinced that it's a viable solution. I mean.
Okay. So George or Andrew, do you have any information that we can already put together in this package that would show data, and also maybe even specific names of people that can be contacted that can give can respond to the effectiveness of this type of a system?
Yes, you know, we have historical work that we've done ourselves, plus work that's been done overseas in Japan, in high-profile places. You know, a high profile here would be the National Park Service. For Disney really doesn't let us openly share data and information just because the way they protect Mickey Mouse. So they're very cautious, and we'd have to go through legal channels in order to share documents from Disney. But we can bring, this is the weird part, we can bring people to Disney and show them what we're doing. And I could possibly get the head of water chemistry to speak to people, but even he has to go to the legal department to get permission to do that. So okay. The National Park Services would probably be a high priority. The Constitutional Lake Gardens we did, and Andrew and I were asked to then propose. COVID messed so many of these projects up.
Okay, so it sounds like National Park Service is one that we can include, which is
a high profile one, you know, that everybody will recognize the opportunity. And then I can supply information from the Imperial Palace in Japan and the airport projects. I can supply that.
Okay, great.
Backyard. So Emilio, for the rest of the group here, we have had a system being evaluated at NOAA in Charleston. We never got a final report from them on it. However, we could give contacts regarding that person that was doing work for us there.
Great. I think that would be very helpful. Dave, did you have an additional follow-up?
Yeah, actually, I maybe Scott Stripling can from Surfrider can help you with that. or at least, you know, reach out to the NOAA guy. Yeah, where is that? Where is the National Park Service? I mean, that's going to be an entity that you know, our scientists will probably look to with a bit of trust on that. Where is that project? What state is that in?
Washington, D.C., right? It's within the shadows of the Washington Monument. It's very close.
Okay.
It was the congressional pond next to the mall in DC.
Okay.
That was a 7-acre lake.
Right. Lake, I should say.
Great, great. So I know we're running up on the last 15 minutes here. So I'm going to go ahead and call on specific people. So be ready. And I want to give everybody an opportunity to ask questions if you haven't already done so. So for the first person here that I'll call on is Petula Burks. Petula, if you would like to unmute yourself to ask any questions here that haven't been answered yet.
No, I'm good. Thank you.
Okay, thank you for that. Umbretta Agro, do you have any questions? Umbretta, if you're trying to speak, you're still muted. I'll wait a couple of seconds here. No? Okay. Scott Stripling, do you have any questions for the team?
No further questions. If you wanted to forward me that no officials email, I'll follow up on that. And Charleston?
Okay. We'll make sure that we email everybody that registered, and we'll also put this information, you know, at least contact information online in case somebody didn't receive it. But we'll make sure to distribute that. Thank you, Scott.
Thank you.
Tanja Morariu, do you have any questions for the team?
No, thank you. I'm very good. Thank you very much.
Thank you. Dave Dobler, do you have any additional questions?
I don't have any additional questions. Thanks.
Okay, thank you. Sean McCracken.
Hi there. Yeah, I do have a quick question about the efficacy in marine environments. I know you mentioned a number of lakes and also I believe Tokyo Bay, right? Do you have additional examples of marine use?
George and Andrew, would you like to take that?
I didn't catch the last part of the voice faded out.
So efficacy
Okay,
in
sorry
marine
about that.
environments.
Yep, you got it.
So George, the question is, do we have data about efficacy in marine environments, since a lot of lakes and freshwaters were mentioned?
Yes, but it's limited.
Okay, so we can obtain whatever we have, right? And we can include that in the package.
Yes.
That would be great. Thank you.
You're welcome.
Okay, thank you for that, Sean. Seth from Surfrider, do you have any additional questions?
Yes, I do. The question that I have relates to duration. Obviously, we are in a crisis situation right now. How do you determine how long to do this? And if it looks like it turns into a long-term situation, is there sort of a, you know, instead of trailer units and things like that, is there a way to convert this into a long-term, more permanent type of structure if needed?
Good question.
That's actually the model that we work off of, using the trailers to go remediate an area, and then we already have permanent systems that can be installed next to the water and just run on a continuous basis.
Great, Seth, does that help, or did you have a follow-up question?
Nope, that's perfect. Thank you very much.
Okay, thank you. Chris Bennett from City of Miami, do you have any additional questions for the team?
Nothing specific yet. I'm glad to hear the names of the groups that are involved with y'all, like Waterkeeper and some of the other groups, because we work a lot with them. We've already got the Waterkeeper kind of going up and down the shoreline of the bay right now, cleaning up a lot of the kill, and with their scavenger and doing some oxygenation as they go up and down as close to the shoreline as possible. So we're trying to at least do a little bit of a stopgap there, if you will. And I'm going to put a message in here for Emilio just to say that from the City of Miami, myself and Director Alan Dodd, who's also our CRO now, if you could just make sure that both he and I are included in any follow-up info on this, because we'll definitely be willing to help coordinate if you're in the city limits of the city, we'll definitely be willing to coordinate, and we might have some generators for you if you're in the city.
Great, great to hear. Thank you for that, Chris. Much appreciated.
Sure.
So, Merle Livand, do you have any additional questions for the team?
No, thank you. I'm really happy to be part of that and hearing everything what you guys doing. As an open water swimmer who choose Miami to train for Olympics, I'm really concerned what's going on.
Thank you. Thank you for joining the call. We will share as much information as possible, as quickly as possible, so we can address the problem. I really appreciate it. Daniel Padilla, do you have any additional questions for the team?
Hi, Emilio. Yes, and thank you. And JP sends his regards, by the way.
Oh, thank you.
I wanted to ask, and I don't know if this was shared earlier because I did join about maybe 20 minutes late. I am wondering if, and I think there was a tie into talking about the necessity for the generators and having access to power, and that's perhaps why Pelican Harbor and also the concentration was identified. But then looking at some of the islands, the man-made islands, and like the kind of natural breakwater effect islands that they have in the middle of the bay, and I'm wondering if those are also sites that we can potentially look at, if it's possible, because they probably have more of like an ecological like importance as opposed to the areas around the harbor. That's what I was thinking.
Thank you, George and Andrew. Would you like to take that one?
I would think it would be up to the scientists for the city, for Biscayne Bay, the waterkeeper, to suggest where they want us to go. I mean, the equipment can be staged wherever we want it needs to be staged.
Great to hear. Andrew, do you want to add to that, or Barry?
Just that it can be staged wherever, but we're going to be able to access. We're going to easily enough where we can keep it through the system.
Okay, Andrew, I tried hearing you. We had some audio issues.
Andrew, your voice is all breaking up. Barry, you want to take it?
Yeah, Andrew, it looks like we can't really hear you too well. Barry, do you want to take that?
I'm not exactly sure what he said. It was breaking up a little bit. As far as placement of the equipment, we've actually had discussions in the past about putting a system on a barge. So that might be an application here. I mean, if you have a big enough barge, you can put the equipment on there. You can put the electric generator equipment on there and move it around. I mean, that might be an alternative too than doing a shore type of treatment.
That's probably a great idea. Make it mobile. Couple hours here, couple hours there. This is you're going around.
Okay, great to hear, Dave. Thank you for that. And I think one of the main takeaways is that that your team from ECE, you're not only taking an equipment and just putting it somewhere, you also have the ability to configure things as needed based off of the specific needs. Is that right, George?
Yes, yes. And, you know, Barry is the expert in the field operationally. He has a long career in the oil and gas industry, which will pay dividends for projects like this.
Great, thank you. Barry, do you want to make a quick comment about that, about customizations and different things that it might be doable?
Well, as you mentioned before, we love to provide turnkey solutions, and we'll accommodate a project to whatever it needs. I don't think there's been anything yet that we haven't come up against that we couldn't provide a solution for.
Great, great. Thank you for that. So it looks like we're getting close to the hour here. So now I'll open it up. Is there anybody else on the call that maybe another question has come up and you didn't have a chance to ask when I called on you? Nope. Okay, great. George, do you want to give any final thoughts? And then Barry, we'll open it up to you for final thoughts, and then Andrew. So George, any final thoughts here?
Final thoughts is we welcome the challenge. Kind of our approach is tell us what you want us to do. We have to understand the scope of the work. Tell us what you want us to do, and then let us do our thing.
Great. Barry?
Good point. We all know on this call this is an environmental travesty and nobody can anticipate. However, that's what gives us focus right now, is to provide a solution to handle this environmental catastrophe. I'm sure that amongst the entire group, our team, external teams, that we can certainly come together and tackle this thing as best that we can.
Thank you for that. Thank you, Barry. Andrew, any final thoughts?
We just need the opportunity to show what we can do. We do have a lot of historical data with it. If there's left and now that is and what it can do, you can look at it. All kinds of information about what it is and what it can do. We believe our technology that we're using is very sound technology. It does a very good job of generating massive amount of data. We get the job done. We just got to make sure we have everything set where we need to be. And we have a good operation going, and we can effectively get that message back up.
Okay, thank you for that, Andrew. You were cutting in and out, but I hope we were able to catch as much as possible. But with that said, it's been about an hour. We've covered a lot of different topics. I hope everybody had a chance to feel like they were heard. And most importantly, we will share information as much as we can, as quickly as possible, via email with the entire team. If there's anything else that we need, we'll ask those questions. We're going to post this entire video online so that it's publicly available. Anybody can see it. We'll share that information as well. If anybody wants to add their contact information to the Zoom chat, feel free to do that. But with that said, thank you very much for joining us. Please feel free to send me an email to contact us, and we will be in touch. So this is definitely not the end of the conversation. It's just the beginning. Thank you, everybody, for joining. I'll wait over here a few minutes, keep the conference line open in case anybody has any additional comments. But for now, the conference call has ended. Thank you for joining on the weekend.
Thank you, everybody.
Thank you.